Good morning, everyone. Welcome to the absolute final, absolute final classwork assignment for the school year. This is, for labeling purposes, the day 168 classwork assignment. It's an FRQ. We will do question number 1. We will skip part C and E. We'll also skip number 2 because these questions have been assigned on the day 168 homework assignment, which was the actual 2019 AP exam. So if you do that assignment, which I want every single student to do, you will encounter these questions there. All right. So we'll skip those right now. Again, for your own sakes, it is imperative to get independent practice. So this is obviously you're doing this together with me, but you absolutely need independent practice just before the AP exam. So make sure you do the day 168 homework assignment. Okay, it was sent yesterday. So we'll start question number 1. We shan't take more than about 10 minutes. Okay. If you'll pause the video, process all the information yourselves. Look at the table, look at the graph, and they give you 2 paragraphs of information. Write down anything that you believe is relevant. So the table gives me a velocity of a particle measured in meters per hour. The graph gives you that of f of x. Okay, it's not f dash, but f of x. So the paragraph says the velocity of a particle p moves along the x-axis. It's differentiable. Okay. Measured in meters per hour. Time is measured in hours. Shown in the table. The particle p is at the origin at time equal to 0. So I can write x sub p. So I'm using their notation of t. But it's at time equal to 0. So we can say at 0 is at the origin. And also says the acceleration of the particle at 1 is negative 10. The second paragraph says you have a continuous function f in the interval negative 6 to 5. Observe the graph. But the graph only shows, the figure only shows a portion of the graph. All right. You have 2 lines and a quarter circle centered at 5,3. Okay. So this is the center of the circle, but you can see. And it says this point lies on the graph. So process that. Please pause the video, do A all by yourselves. It's a very basic problem. So I need to find the derivative of a product. So I can use product rule. So f of t times vp dash of t plus product rule vp of t times f dash of t, but evaluated at t equal to 1. So sub. So I'll plug it in. So f of 1, show that step. And then vp of 1 times f dash at 1. See if we can finish the problem. Now f of 1 is given to be from the graph to be 1. Vp dash of 1, wait a second. Isn't that the acceleration at 1? Negative 10 plus Vp of 1 from the table is negative 29 times f dash at 1 is a slope at 1, which is just 2, right? Rise over 1. Here's an AP tip. Do not simplify this. Just stop. Leave Brittany alone. You do not get extra points for simplification. Okay? Just stop right there. Attempt part B yourselves. Pause the video. So part B says use a trapezoidal Riemann sum to approximate the value. So use the approximation symbol. In case you've forgotten the trapezoidal rule, it's the average of the parallel sides, which are the y values. So 0 plus 55 over 2 times distance between the parallel sides, 0.3, plus 55 minus 29 over 2 times 0.7, plus negative 29 plus 55. Observe the domain. We stop at 2.8 over 2 times 1.8. Here's a tip. Stop. Don't even simplify this. Again, anything that requires complicated arithmetic simplification, don't even bother doing it. Just leave that alone. Okay? If you have time, do so. But if you don't have time, you can just stop. You're fine. A small thing. Now, this is obviously the displacement. Okay? It's the integral velocity. But assume it was 0 to 2.8. I'm just showing you a concept. Absolute value of Vp of t. The interpretation of that is the approximate distance, okay? Because it's a Riemann sum, so approximate when you interpret. But I'm showing you, some of you make errors. I want to show you this guy because some of you make mistakes in taking absolute value. The correct answer is 55 plus 29 over 2 times 0.7 for the middle expression. Many of you write this erroneously. You put 55 minus 29 over 2 like this, and you just put an absolute value here. That is incorrect. Because the expression over here says take the absolute value of every velocity value, or absolute value of the velocity function. So observe that, please. We're skipping C. We'll go to D. It says evaluate that expression. You can pause the video, attempt it yourselves. So we can split up the integral. So it's 2 integral 3 to 5 f dash of t dt operator. Many of you forget the operator, plus integral 3 to 5 4 dt operator. Whoa, what does the first guy remind you of? The correct answer is net change. So it's actually f of 5 minus f of 3. Show the step. Plus, for the second guy, it's just an integral. The integral of 4 is nothing but 4t. Lower limit 3, upper limit 5. 2 parentheses. What's f of 5? 0 minus f of 3. If you're alive, they actually gave this weird point here, remember? So f of 3 is nothing but 3 minus radical 5. But careful, you can make mistakes. That's in parentheses. Careful. Okay? And then evaluating the definite integral, 4 times 5 is 20, minus 4 times 3 is 2. When you open up the parentheses, it becomes negative 3 plus radical 5, plus 8. You can stop right there. You don't need to simplify arithmetic. Stop. You could simplify, don't get me wrong, but you'd be fine. Okay? You're doing E yourselves on the take-home test. We'll do F. F says using G of t from part E, okay, that's G of t, is the rate of change of G increasing or decreasing at t equal to 3. Careful. Interpret the problem exactly the way it's written. What are they asking for? So it says, is the rate of change of G increasing or decreasing? They're basically talking about G double dash of 3. That's what the question is all about. So should we first find G double dash of x? Isn't G double dash of x? First, find G dash of x, show the work. G dash of x is nothing but f of x. And therefore, G double dash of x is f dash of x. And finally, therefore, we need G double dash of 3. Isn't that basically f dash of 3? Can we just read the graph? And f dash at 3 is negative, correct? Less than 0 from the graph. I'm clearly telling you how. From the graph. Write a conclusion yourselves. Get it from the question. So the correct answer is the rate of change of G is decreasing at t equal to 3. Okay? You can pause the video, attempt G all by yourselves. So as I said, in the recent past, I've asked a lot of questions like that. They usually come in MCQs, but in the recent past, they've appeared as FRQs, which is why you really, really want to do the 2017 to 2019 exams completely to get the practice. But otherwise, how do we always do limits? evaluate the function. So sidebar, so that's e of 1 minus 3 f of 1, correct, over vp of 1 minus cos pi. So that's e minus f of 1. And f of 1 is nothing but 1. Okay. Over vp of 1 is nothing but negative 29. And cos of pi is negative 1. So absolute final answer is e minus 1 over negative 30. Yeah. So you may be tempted to use L'Hopital's rule, but you really didn't need to. We did not get 0, 0. So we're done. All right. We'll go to the second document. You can pause the video. We are going to the second document. Okay. Again, I strongly recommend that you have done the 2019 exam before you do this video. So if you have not done the 2019 exam, which is the day 168 homework FRQ, please pause the video, come back to it. Because there's a question like this, not exactly this one, but there's a question like this. If we do this right now together, you're basically getting a peek at the problem. So again, stop watching this video if you have not done the day 168 homework. All right, assuming that you have, let's finish this question. We'll do as many parts as we can till the 15-minute mark. So it says f and g of x, f, g, h are twice differentiable, and they're giving you that information so you can process that. This is document 2, okay? So they're giving you that information. They also say the line, this is tangent to both g at x equals 5 and h at x equals 5. So that's the equation of tangent line. You can pause the video, attempt A yourselves. So it just says find g dash at 5. So keep in mind, this line is the equation of the tangent line to g at 5. So isn't g of 5 nothing but the slope of this line, okay, which is negative 5/3. That's it. Okay. Pause the video, attempt B yourselves. So b dash of x, should we just use the product rule? So 2x squared times g dash of x plus g of x times 4x. Rewriting is your friend, so it's 2x squared g dash of x plus 4x g of x. And they say find b dash at 5. So b dash at 5 is nothing but 5 squared is 25 times 2 is 50. G dash at 5, show the work, plus 4 times 5 is 20, G of 5. Okay, look at all the information we have and we're given to finish the problem. G dash of 5, oh, the AP is guiding you, is negative 5/3, plus 20 times G of 5 is given to be 1. And stop. Don't even simplify this. Don't even bother simplifying this. We're good. We're good to go. We're good to go. Good to go. All right. We'll do C in the next video.